Good afternoon, everyone. My name is Christopher Marion, and I am a CAM specialist for SolidCAD in Windsor, Ontario. Today, we'll look at programming a common mold plate using PowerMill. If you're not familiar with PowerMill, PowerMill is a standalone CAM system that excels in fast calculation time, toolpath editing, toolpath safety, multi-axis control, and automation. We'll go through how PowerMill can handle this type of part, give you some additional twists on some different types of programming along the way. The purpose of this webinar is to give you an idea of some PowerMill's tools and getting new programmers comfortable with using them. We'll cover a variety of topics here, including creating whole feature sets, programming traditional drilling toolpaths, creating drilling methods for automation, some basic toolpath editing, creating feature groups, adaptive style roughing, machine simulation, and what it can provide for us. So with that being said, let's get started. Just a quick tour of the PowerMill interface before we begin. For those of you that have not seen PowerMill before, PowerMill utilizes a ribbon style interface, something comparable to that of anything you would find in a Microsoft product. Each one of these tabs contained groups of functions. The very top of the interface is our quick access toolbar. This quick access toolbar allows me to take any of the commands that I'd find within the ribbon and place them up here for quick use. PowerMill is also very customizable with regards to user-defined macros. These macros can also be placed on my own custom tab. The Project Explorer on the left-hand side contains any entity that I've created this far in the project, or maybe any item that I've imported into the project. On the far right-hand side is our viewing toolbar. This contains some manipulation tools, some shading options, as well as some selection tools. Our graphics window in the center, this is where all of our work is done. The top right-hand corner of this graphics window is our view cube. It's more of an interactive method of manipulating my model around by clicking on these interactive tiles. The center of my window, this is our world coordinate system. And at the very bottom, our status toolbar. This just gives me some feedback as to what unit of measure I'm working in, and coordinates of my mouse pointer and the Cartesian workspace. So to get started here, I'm just going to go ahead and turn on our mold plate. I'm just going to bring this up in the extent of my graphics window. In this world coordinate system, I want to override that with my own datum. So the first thing I'm going to do is I'm going to go into the toolpath setup group and I'm going to define my own datum. I'm going to snap that to the bottom left-hand corner. Go into my work plane branch. I'm going to rename this and activate it. Activating this work plane now tells PowerMill that we're going to use this as my new coordinate system over that of the world. So with that being said, I'm just going to undraw the world since it's no longer needed. So I'm going to go back to the toolpath setup group. I'm going to define a block. So there's different methods that I can define this block. I can use a standard block, a cylinder, or in this case, I'm going to import an outside file. So as you can see, I've imported this stock. The stock's already got a couple open ends within the two rings here, as well as the top and bottom of this plate. This is going to represent that this plate's already been sent out for a flame cut. Just going to accept that. I'm just going to go up to the toolpath connections tab here. Underneath safe area, I'm just going to re-establish my safe zone. So before we get started on any type of drilling toolpaths, what we need to do is extract the information from the model. So I'm going to go back up to the tabs. I'm going to go into the whole feature set tab. I'm going to box select the entire model. I'm going to go ahead and create holes from the model. Now, something that's very important to me is color coding my models appropriately. This just alleviates any of the guesswork for the programmer. So these pink holes, these could represent clearance values, a press fit, a counterbore hole, as well as a tapped hole. So the very first thing we're going to concentrate are on these pink holes. These will be clearance. So I'm going to go to the Explorer, expand my Tools branch, expand the indexable folder. I'm going to go ahead and select my 1¼ with a 3mm tip radius tool. I'm going to go back up to the Home tab. I'm going to go into the Toolpath Strategy selector. Think of this as a library. We've got common roughing toolpaths, standard finishing toolpaths. Got some more strategic type toolpaths like turning and probing. Then we have our drilling toolpaths. So within the drilling tab, I'm going to go ahead and select helical. So the very first thing I'm going to do is just define an identifiable toolpath name. Let's call this pink helical. So I'm going to define the top of my hole by the hole top. And I want to drill, or mill this case, through the hole. So basically I want to compensate for the tip radius of the tool. So in the pitch, this is for every revolution, how far down my tool is going to go. So just to kind of speed things up, I'm going to take 1/8 of an inch. Before I hit calculate, I'm going to use my filter to dictate which holes I'm going to work on. So in the filter, I've got select by diameter. This is the default method. If I knew which diameter it was, I can take the diameter and bring it over into the selection filter. In this case, since I'm using colors, I'm going to go ahead and select the color option. Select the pink and bring it into the filter. Let's go ahead and close that. And I'm going to calculate. I'm going to go ahead and close that. If I want to visualize how this toolpath is going to behave, I'm just going to expand my toolpaths branch. Right click on the toolpath. This is going to bring up a menu. The very first option here is simulate from start. I'm just going to automatically go into my simulation tab. I'm just going to go ahead and hit play. So kind of visualize the behavior on each one of these holes. There's no need to watch the entire toolpath play, so I'll just go ahead and pause this and bring it back to the beginning. So next set of holes we'll look at are these cyan holes. These cyan holes are going to be press fit. So instead of just doing a single operation, I might incorporate more than one, maybe a mill and a ream cycle. So before we go any further, I'm just going to go ahead and select my 1" 62 thou tip radius tool. Go back to the Home tab and go into the Strategy selector. Underneath drilling, I'm going to utilize the helical cycle again. So let's call this one cyan helical. And again, I'm going to leave these values the same. One thing I'm going to change is the pitch. I'm going to go 100 thou this time. And I'm going to change the thickness since we're going to leave some stock on here for the reaming operation. I'm going to go back to the selection filter, remove the old filter, and add in the cyan. Let's calculate this. We can see the toolpath in the screen. So instead of closing this form, what I'm going to do is click on this button. This is the clone function, which is going to leave the toolpath form open and allow me to create a new toolpath. I'm just going to rename this before I go any further. Let's rename this ream. go into the tool. Let's go ahead and select my reamer. Go back into the drilling page. So instead of helicaling this hole, I'm going to ream this. I'm also going to turn on drilling cycle output. This will use CAN cycles in my NC code. The thickness, I'm going to bring this back to 0. And the hole's already been selected, so there's no need to go back into the selection. I'm just going to hit calculate. Okay, so let's go ahead and close this. Let's take a look at these purple holes. So these are clearance for 1/2-inch tap screws or cap screws. So what I'm going to do is go into the drill folder. I'm going to select the 35/64 drill. This will be the clearance for these cap screw locations. So I'm going to go back into the toolpath strategy selector. Since I'm using a carbide drill, I'm going to go ahead and select the single peck operation. Let's rename this. Utilizing a G81 cycle, I'm going to start at the top of the hole. I'm going through the hole again. You can see the depth's already been pre-established. I'm going to go back into the select option. Since I'm changing colors, let's remove the filter to the purple. Let's go ahead and close that. I'm using CAN cycles once again. I'm going to go ahead and calculate this. And again, I'm going to clone the toolpath. So now we're going to look at milling the top portion of this hole. Let's go into the tools page. Let's go ahead and select a 3/8 end mill. Go back into the drilling page. So again, I'm going to utilize a helical cycle. Change the pitch to 25 thousandths. The hole's already been selected. So let's go ahead and hit calculate. So one thing we have to be very wary about is that since this hole has got multiple components, that 3/8 end mill can fit in the top component as well as the bottom component. So in this drilling form, we have the option of using a range. So I only want to focus on the top component. So this is going to be component number 1. And I don't want to go through. I want to stop at the depth of the hole. So this depth. Let's recalculate this toolpath. And you'll see that it stops in the bottom. Let's go ahead and just rename this before I close it. And hit close. Okay, so we can do the same thing with these blue holes. But in this example, we're going to look at some automation. So I'm going to go into the strategy again and look at drilling methods. So drilling method is the option for me to create a process for each type of hole. So that way I have access to these every single model that I might be working on in the future. So I already have an example of this method. I'm going to go ahead and close this. Go back into the strategy selector and look at my cutting template file. Blue holes. Go ahead and hit OK. As you can see, we have a couple processes. A process for the blind holes, which are from the top of the plate, and a process through the through holes, which are from the bottom of the pocket. Each one of these processes have different type of filters. So let's go ahead and hit apply. So once the process runs through, we can see we've got 6 toolpaths. 3 for the through, 3 for the blind. Okay, so let's go ahead and set up our own process for the holes that we already established, these guys. So let's go up into the strategy selector, drilling method, and create a new method. So there's a couple different ways we can create a method. When we create a new drilling method, PowerMill starts me off with a process and a single pec operation. So the first thing I'm going to do is select the process and rename it. I'm going to rename this pink. And the single pec has no information. I'm going to delete that. I'm actually going to import an existing toolpath, which has all the information already. I'm going to create a new process. This is going to be for my cyan holes. I'm going to add the helical operation as well as the ream cycle. Let's create another process for the purple holes. And again, I'm going to add both of those operations. Okay, let's close this. Before we go any further, we just have to set up our filters. So I'm going to select the pink process, add the pink over for cyan and for the purple. Just verify. Looks good. So I'm going to go ahead and save this so I have access to it in the future. So let's call this one mold plate example. And hit save. So I'm going to close this method out. Delete all these old toolpaths. Go back to the strategy selector. Underneath cutting templates, you can see my drilling method here. Select it, hit OK. So let's make sure that this works. I'm going to hit apply. Let's go ahead and close this. As you can see, we've got our 5 toolpaths. So I'm going to select these, just place them in sequence, and delete the method there, since I have it backed up in my folder locally. So let's go ahead and look at this pocket. If I were to run these toolpaths in sequence right now, I would probably have some kind of a gouge into the stock where this pocket lies. I can visualize that by going into my simulation tab. Let's go ahead and activate this toolpath. I'm going to turn on my view mill. Let's go ahead and simulate this. Okay, as you can see, PowerMill stops when there's a gouge. It's going to show me where that gouge is. So I'm going to bring this back to the beginning. Let's clear out the issues. I'm going to turn off the view mill. So let's look at this pocket. So I could use some traditional toolpath methods. In this case, I'm going to use a feature method. So PowerMill has the technology inside to extract this as a feature. So I'm going to go ahead and detect these features. As I move my mouse over the model, you can see the features will highlight. So I've got a circular pocket, rectangular pocket. So I'm going to select that rectangular pocket and hit accept. Now I have access to some feature machining strategies. So I'm going to go ahead and hit the feature area clearance. Anytime we see area clearance, it's normally a roughing strategy. So I'm going to select an appropriate tool. Go back to my feature area clearance page. Now it's just a matter of me selecting which type. So for this example, I'm going to select an adaptable. That'd be Vortex. So with Vortex, we also have two different methods. So from model is Delcam's method, and from stock came from HSM. So in this case, I'm going to use from stock. Retract on non-cutting moves. I'm going to tell it to never retract. And I'm going to increase my non-cutting feed rate to 150 inches per minute. Go back into my feature area clearance page. Since adaptive allows me to take a larger axial depth of cut, I'm going to change my step down to 1 inch. I'm going to change my step over to a little bit smaller than what I'd normally take on a step over. Leave 20 thousandths for thickness, and I'll leave 5 thousandths for tolerance. So the purpose of adaptive, again, is to take a larger depth of cut, a smaller radial depth of cut, but PowerMill will never exceed the engagement angle when it gets into these tight corners. Once it finds the engagement angle, you're going to see some trochlear type movements. This is going to allow the feed rate to stay consistent and never shock the tool. Shocking the tool is what's going to result in tool breakage. If you're going to incorporate an adaptive strategy, I would highly recommend that you talk to a tooling specialist first. So let's go ahead and rename this. Instead of hitting calculate, I'm going to click on this Q function. So queuing will calculate this in the background and it'll allow me to continue to work in the foreground. So I'm going to create a finishing operation. Okay, let's call it green, pocket, finish. So I'm going to select a raster option to finish the flats. The wall cut distances, let's go 1/8 of an inch. The flat cut, 3/8. And then the raster, I'm going to change this to 90 degrees to cut with the length of the pocket. Let's hit calculate. And close. As you can see, our finish operation calculated, as well as our roughing strategy. Just looking at the finishing operation, if I wanted to change where the toolpath started and stopped, maybe I want to start at the top of the pocket, I'm going to go ahead, go to my toolpath edit tab, move start points, and draw a theoretical line that crosses my toolpath segments. You can see it'll update this automatically. Let's go ahead and accept that. Let's go back to our roughing strategy and take a look at this. I'm going to go back into my simulation, turn on my ViewMill on my 3D simulation. Let's go ahead and simulate this from start. Let's go ahead and hit play. So I'm just going to bump up the feed rate. As you can see, when it gets in the corners, it removes those stock. Let's go ahead and activate the finishing operation. Simulate from start. Slow down the feed rate a bit. Hit play. Okay, so now if we were to run that center drill operation where it was gouging before, simulate from start, slow it down just a little bit, hit play. You can see there's no gouges since the stock started being cleared out. So I'm just going to go ahead and close ViewMill and continue on. Okay, so let's look at these red pry slots. So I could use some feature machining or maybe some curve machining or some other traditional type machining In this case, I'm going to do things a little bit differently. I'm going to incorporate a finishing type strategy, even though that there's some stock that needs to be removed out of here. So I'm going to select the sidewalls, go back to the Home tab underneath the strategy selector. I'm actually going to go into the finishing strategy. I'm going to go ahead and select a swerve finish. Hit OK. So it's important to note that swerve finishing out of the box is a simultaneous live 5 type strategy. So I'm going to go into the tool axis page. I'm going to change this back to vertical to keep it 3-axis. The reason why is because PowerMill wants to lay the end mill against the ruled surface. That's why the tool axis goes to automatic. Since I want to keep it in 3-axis, I'm just going to change it back to vertical. So let's go into the tool, select an appropriate tool. In this case, 5/8 end mill. Go into the swerve finishing page. I'm going to change my cut direction to climb. Multiple cuts. I'll go 30th step down. Okay, so if I were to take a look at this toolpath, I could see I've got some large arc moves, which are a little bit inappropriate. So it's really important to note that in PowerMill, I never have to recalculate the toolpath if I want to change the non-cutting segments of my toolpath. This would be any linking moves or any lead and lead out moves. So I'm just going to rename this toolpath. And hit close. Because again, if I want to edit this, I'm going to go into my toolpath edit tab, toolpath connections, lead in. You can see it's applying a horizontal arc at 90 degrees. The radius, I'm just going to make it a little bit smaller, 1/8 of an inch. Make them both the same. That's the lead in and the lead out. Hit apply. There we go. Now what I might want to do is add an extension move or a linear move so that my tool plunges outside. So I'm going to go ahead and add a 320th linear move. Make both my lead in and lead out the same. Hit apply. This as well. This is a linking move. Since I want to avoid the tool retracting unnecessarily, I'm going to change this to on surface. Hit apply and accept. I'm going to apply the same type of toolpath on these orange cutouts, just to kind of keep this webinar moving along. So I'm going to select these faces, go to the Home tab, Toolpath, Swerve, and remember, first thing I'm going to do is go into the tool axis page, change this back to vertical to keep it in 3-axis. I'm going to go into the multiple cut page. I'm just going to change this to 1/8 of an inch. And in my limit page, I'm going to make sure that I'm allowing my tool outside my stock. Let's go ahead and hit calculate. So as you can see, I've got my extended move as I did on my red slots, as well as my 1/8 radius. But I'm getting a retract move once again. So I'm going to go ahead and hit close. I don't need to recalculate my toolpath. Let's go into the toolpath edit tab, go back in the toolpath connections. I'm going to go on my links page. I've got on surface, but I'm only applying an on surface if the moves are under 1 inch. So I'm going to change this to 5 and hit apply. Since this gap between here and here is under 5 inches, it's going to fill that in with an on surface move. I'm going to go ahead and accept. Let's go ahead and zoom out. So the last item that we need to concentrate on are these rings. So I'm going to go back and select my 3/4 inch end mill. Let's focus on these rings. Okay, since the stock's already been flame cut out, there's only about 1/8 of an inch of stock between the flame cut and this interior ring face. We go back to the Home tab, Strategy Selector, Drilling, and do another helical operation. I'm going to call this one Ring Center. Now I'll only concentrate on the second component, which would be this interior. I want to focus on the top of the hole, and I want to cut to the hole depth. The pitch, make it rather large, 1/4 inch. I'm not going to leave any thickness since this face really doesn't mean anything. I'm going to cut it right to 0. Go in the selection, remove out the filter, add my filter. Let's go ahead and hit close and calculate. Okay, so I can see this really large arc move. So I'm going to go ahead and modify that. Recycle this toolpath. I'm going to go into the lead out page. I'm going to change the lead out distance to 1/4 inch. Okay, let's go ahead and hit close. Now I'm going to focus on this step. I can't really helical this step because I only have a 3/4 inch end mill, and this distance is larger than 1/4 inch or 3/4 inch. So let's go back into the strategy selector. This time I'm going to incorporate a profile type toolpath. Okay, so I'm going to profile this top portion of the ring. So again, I'm going to utilize the range function, and I only want to concentrate on the top component. So I'm going to start at the hole top, drill to the hole depth. The peck depth, whatever that distance is, if I don't know it, I'm going to go ahead and hit this blue hyperlink to bring me to my measurer. I'm going to select this distance. Let me just adjust this real quick again. Okay, so the depth, 6255. I'm going to do a spiral option. And then the profile page, the spiral will be my step over. I'm going to leave it at 80 thousandths. And my lead distance is going to be this distance. I'm going to go ahead and add another 50 thousandths, just so it starts off the stock. Let's change this to ring step roughing and hit calculate and close. Actually, I'm going to go back into this toolpath settings real quick because I want to leave a little bit of stock on this interior face. And hit calculate once again. So I want to create a finishing operation, just a one pass. So let's clone this or copy this toolpath. I'm going to rename this finish. Change my thickness to 0. Remove the spiral. I'm now going to turn on cutter compensation so that when I run this on the machine, I can adjust it like so and hit close. Okay, so one thing that I might want to check before I run this within any NC code is to verify that all my toolpaths are in fact safe. So when I calculated these toolpaths, you notice these little check marks. That's PowerMill's way of telling me that this toolpath is gouge free. This toolpath is unknown. So what we really want to do is get this toolpath safe from the cutting edge to the shank to the holder. So I'm going to go back up to the Home tab and toolpath verification. I want to check for collisions. I don't want to split the toolpath. Holder clearance of 1/8 of an inch. I don't want to adjust the tool. Just tell me if there's a collision or not and hit apply. No collisions were found. So it brings that status light to blue, which is the highest level of status within my toolpaths. So as you can see, this would take me some time to go through all these toolpaths. So what I'm going to do is incorporate a macro. So I'm going to go to my ribbon, collision check. I'm going to check within 1/8 of an inch, 0 on the shank. Just going to go ahead and select all the toolpaths I want to verify. PowerMill will start at the top and work its way down to the bottom. The purpose of these automated macros, it just saves me a lot of mouse clicking. Okay, so I've got blue check marks all the way through. I'm pretty happy with that. So let's take all these toolpaths and let's add them to my NC program. Add to the NC program. And before I export this out into some NC code, what I might want to do is verify that all these toolpaths are safe in the machine environment. So let's go ahead and turn on my levels, which represent my fixtures. Let's go up and turn on my machine simulation file. So PowerMill simulation file will pause and tell me if there are any warnings with any collisions between any of the machine components or the holder. So I'm going to go ahead and hit OK. Go to the simulation tab, display issues. Let's just clear that out and send the machine back to its home position. As you can see, I've got my mold plate and my fixture kind of sitting inside the machine. So it's up to me to basically tell PowerMill where this is sitting. So I'm going to incorporate a work plane that tells PowerMill that where this is sitting on the table. Okay, so I'm just going to undraw these toolpaths, undraw my tools. Let's go ahead and simulate this on the machine. Okay, so let's zoom in real quick. I'm going to go ahead and hit play. Starting off with these pink clearance holes. And then we'll go over to the cyan helical operation next. As you can see, this is taking some time. I really don't want to sit and watch all these toolpaths play out. So I'm going to go ahead and hit pause, send this back to the beginning, go back to the Home tab, and I'm going to incorporate a different type of verification, NC program. So before I can do this, inside the NC program settings, I need to tell PowerMill which simulation file am I using and where is it sitting. Let's hit accept. I'm going to verify all my toolpaths, verify any collisions between any of the components within 1/4 of an inch, and verify. So if there are any issues arise, this window will populate with them. Okay, so I can see the first issue. PowerMill, the tool wants to go to X21.822, but the maximum is only 21.5. If I look at the machine, you see the column of the spindle is offset to the actual spindle itself. So I might be able to mimic the machine in a way to avoid this limitation issue. So I'm going to go ahead and select this and load the issue. PowerMill will bring me to where it needs to get to. I'm going to go ahead and hit close. And I don't need to recalculate the toolpath. What I'm going to do is go into the toolpath edit tab, and I'm going to use the dynamic machine control. So the dynamic machine control is a really diverse type of editing tool, which allows me to use the machine simulation file and mimic the rotary axis in a way to avoid any type of limitation or collision issues. So I'm going to go into the machine tool position form, place 90 degrees in the C-axis, hit close, simply update the toolpath, and hit accept. Since the blind drill and tap are probably going to have the same type of orientation, let's just go ahead and hit activate. Simulate from start. Toolpath edit, dynamic machine control, tool position. Let's make this 90 degrees as well. Update the toolpath, hit accept. And I'm going to do it with the blind tap as well. Activate. Simulate from start. Dynamic machine control. "90 degrees. Hit close. Update the toolpath. And hit accept. So let's go back up and verify this NC program once again. And again, if there are any issues, this window will populate with them. Okay, so no issues popped up. I got green check marks all the way through. I'm pretty satisfied with this. So I'm going to go ahead and write the NC program. Okay, everything's post-processed. I feel safe to run that on the machine. I'm just going to go ahead and simulate this once again. So as this is playing through, I'd like to just say thank you to everyone who participated in today's webinar. Just stay tuned for more of these in the near future. Hopefully we get to show you the full potential of using Autodesk CAM software to meet your manufacturing needs. Just to kind of recap what we looked at today, looked at some traditional type drilling toolpaths, looked at some drilling methods to start with some automation, looked at some feature recognition, adaptive roughing strategies, some basic toolpath editing, toolpath verification, machine simulation, as well as some NC program verification. So at this point, I'll go ahead and open up the dialog for any questions or comments that you might have. Thank you very much.